Today we're going to learn about real numbers. Real numbers are all numbers on a number line: positive, negative, fractions, decimals, repeating decimals, ending decimals, and decimals that go on forever and have no pattern at all to them are all real numbers. Real is the opposite of imaginary. There is a such thing as an imaginary number, which you will learn about in high school. We're not going to worry about right now. But real numbers are all of those numbers that you can find on a number line. Real numbers can be split into two categories. Irrational numbers we're going to put over here in this box. Irrational numbers are kind of like an irrational person. An irrational person would be that person who rambles on, maybe about something that makes absolutely no sense, and you don't know what they're talking about, but they never stop. They just keep going and going and going. That would be an irrational person. Irrational numbers are just like that person. They continue on and on and on, and they never stop, and they don't make sense. There's no pattern, no rhyme, no reason to them. And you can't guess what's coming next. It's always something different. Some irrational numbers would be numbers like pi is an irrational number, which is 3.14, and it continues on and on and on without a pattern at all. Another irrational number would be the square root of 21. It is a decimal number that continues on and on and on. It has no pattern to it. So those are two examples of irrational numbers. Any decimal number that continues on and seems to have no pattern at all whatsoever, and just keeps on going, would be an irrational number. Well, in the other subset, we have rational numbers. Rational numbers make a lot more sense than irrational numbers. The rational numbers are numbers that can be written in the form of a fraction or a ratio. They're called rational numbers because the root word for rational number is ratio. You can write it in the form of a ratio. Some examples would be 1/2, 3/7, 25/100, 342,000. Any number that can be written in the form of a fraction, that any decimal number that ends, or even a decimal number, for instance, like 7/9 would become 0.7777, repeating. Any number that repeats, it makes sense, you can guess what's coming next, is a rational number. Well, rational numbers have some numbers that also fit into this category. Integers fit into rational numbers. So let's add integers to this group. I'm going to separate it off a little bit from the rest of these numbers up here, because these numbers are not integers, but integers are rational numbers. Integers would include both positive and negative numbers on a number line. Integers would be numbers such as -6, -3, -2, -1, and so on. It would also be +6, +3, +2, +1, but that fits into the category of a whole number, and whole numbers are integers. Okay, whole numbers are integers. Whole numbers would be 0, 1, 2, 3, 4, and so on. I'm going to put 0 here. Excuse me. I'm going to put 0 here. And numbers 1, 2, 3, 4, 5, 6, I'm going to put in a separate section called natural numbers. Natural numbers are whole numbers. Natural numbers are also integers, and natural numbers are also rational. Natural numbers are numbers that you naturally count as a child. When you start counting, you count 1, 2, 3, 4, and those are your natural numbers. Natural numbers are whole, so they're part of this category. And natural numbers are integers. Whole numbers are integers. And all of these are rational numbers. I can write any of these in the form of a fraction. 0 over 1 is 0. Negative 6 over 1 is negative 6. 4 over 1 is 4. I can put all of these numbers over 1 and write them in the form of a fraction or a ratio, and that's how they are a part of the category of rational numbers. All of these numbers can be found on a number line. Take a look at a number line. Okay. On this number line, we can find real numbers. We have our natural numbers, 1, 2, and 3. We have whole numbers, 0, 1, 2, 3, and so on. We have integers, which are our whole numbers and their opposites, negative 1, negative 2, negative 3. We also have our rational numbers in the form of a fraction. We have fractions that are in between our whole numbers. So between the 1 and the 2, we have 1 1/2. Between the 2 and the 3, I could say there's 2 3/4 over here. Negative 1 3/4 over here. So there are rational numbers all throughout this number line. And there are irrational numbers. There are numbers that continue on and on and on, that come between 0 and negative 1, between 0 and 1, between 1 and 2. But there are irrational numbers that continue on with no rhyme or reason. They have no pattern, they don't end, and they don't repeat. So you don't know what's coming next. But they are located in between these whole numbers or these integers on the number line. There are terminating decimals up here. 1 3/4 can be written as a terminating decimal. A terminating decimal is a decimal that has an end to it. Decimals that end are terminating decimals. I can write negative 1 3/4 as negative 1.75. And that's an ending decimal. It stops there. Repeating decimals are decimals that have a repeating pattern. Repeating decimals are decimals that have a repeating pattern. So the pattern is going to continue on and on and on in that decimal. For instance, if I had, let's say right here is 7/9, which would be 0.77 repeating. To recap, we have real numbers, and real numbers are all numbers on a number line. There are two categories of real numbers, which includes irrational numbers and rational numbers. Irrational numbers are numbers that have no end or pattern to them. Rational numbers are numbers that can be written as a ratio, hence the word rational. We've got the root word ratio in the word rational. And create terminating or repeating decimals. So if you tip over the ratio and you divide it out, you're going to end up with a repeating or an ending decimal number. In the rational number category, we have integers, which are whole numbers and their opposites. Whole numbers are 0 and all natural numbers, and this fits into the integer category. And natural numbers, counting numbers, 1, 2, and 3. And natural numbers are whole numbers. Natural numbers and whole numbers are integers, and all three are rational numbers. At this point, I want you to take a look at the numbers that I've placed down here in the corner, and I want you to decide where you think those numbers belong. I want you to add them to this graphic organizer in your composition notebook. So these are your numbers, and I want you to make a decision. So 2/3. 2/3 is written as a fraction. It is a rational number, and you should have put it in this category right here. -5. -5 is written as a whole number, as an integer. It does go under rational numbers because I can write it as -5/1, but it fits into the integer category. 1. 1 is a whole number. 1 is a natural number, so that would go here. -2 and 67/100 would also belong in the rational number category. So that's going to go in rational numbers. -6. -6 is going to belong in your integers. It is a rational number because you can put it over top of 1, but it fits in integers. 8.63291, I don't see a pattern with this at all, and it seems to continue on. That's going to go in irrational numbers. 0, 0, you would put in your whole number category. And 5 and 4/10 repeating. This is repeating, and so I know that repeating decimals make sense, and that would fit in the rational number category.